Hello and welcome. In this session, we will analyze the dataset of chess.com, which I have downloaded from Kaggle. And here we will do some basic operations like load the data, perform cleaning, and get the correlations, EDA insights, heat map, etc. Let's get started. The first thing we have to do will be to load the data of chess.com that is present in a CSV file through our Databricks platform. To do so, go to the Databricks platform and click on this plus icon. Here, select table and let's upload the file. And the name of the file here is Club Games Data. Let's open this. This is a pretty big file, so it will take some time to upload. And let's wait for it. Our CSV data file has been uploaded, and the next step we have to do is open this in a notebook. Let's select the option create table in notebook. This will give us a few overview and some basic code blocks for execution. We will not be using them. Let's delete all these code blocks and create our own. Let's also rename the table as chess and let's select our compute. If you have not created a compute, you can just create one. It's pretty simple. The first thing we will be doing is importing some important functions from PySpark. So let's run this. These will be the simple functions we are importing. The next thing we will do is define schema for the chess games. So it's this. This is the chess schema, and we are creating the schema first to define the types and everything. That is the white username and the black username. So white ID, black ID, the ratings and time controls and rules. This is just some simple schema for our function. Now let's go to the next cell. Here, what we are doing is creating a DF. So we will be using DF for everything to load our data into data frame and perform functions on it using Databricks. And let's run this. And our DF is loaded, and you can see it's loaded in the schema we decided. Now let's go to the next cell, and in here we will print the basic information. So print total number of games. So df dot count, df dot print schema, and let's just show the first 10 rows. Let's run this. This will just count the total number of games and show the first 10 rows. Let me zoom out a little bit. And here you can see the first username is Amos and the opponent of his was Miniman. And white user's rating was 1708 and black user rating was 1608. With pretty basic patch, and pretty basic results. Now let's move on to the next step or the next cell. Here, what we will do is clean the data and handle the missing values and the duplicate data. So as you can see here, there are some few null values. So these are the missing values. Now let's clean this data. We will use clean underscore df dot drop duplicates. And now let's print these records. Let's run this. This will clean our data, and there seems to be some issue. Subset what data result unexpected character. I have updated the query. It was not much of an issue. And let's after running the job, it will take around a few minutes to run this query because the data set is around like 15 lakh games. So let's wait for it. And our records are now cleaned. You can see the total number of records after cleaning is 51,693. Now let's move on to the next block. And here we will add derived column for analysis. And this is the query. So let's run this. So the query has now run. The next thing we will do is rate the distribution analysis. Let's write the query. This one. Let's copy this, and because we have to okay, next line, we will paste it again. Now in here, let's change this white to black and average black rating. Now in the next line, we will create standard deviation STDV for white rating. Then give alias and have standard white rating. The same for black. Let's copy it and it should be underscore. And let's give dot show. Let's run this. This will calculate basic statistics for rating, and the output will be the average and standard deviation. It will also help understand the rating distribution, and this will take a few minutes, could be upwards of 5 minutes to run this query. Let's just wait for it. And our query ran successfully. So it's giving average rating for white user and average rating for black piece user and standard deviation for both white and black. Let's go on to the next cell. So for the next one, what we'll be doing is this. So what this code do is calculate the win rate for white players based on rating differences in chess games. It groups games by 100-point rating buckets, count total games, computes white win rate per bucket, and sort the rating differences. Let's run this. Our output came in like 2 minutes. So what this output shows is the chess game statistics grouped by 100-point rating difference. So if rating difference bucket is 100, and it also shows the total games in each bucket and the win rate for the white players in each bucket. So if rating difference is minus 1900, total games played is 1. So meaning if someone has a rating of 100 and other one has 2000, so and there is total chance of winning for the lower rate person is zero point 0.0, and as you can see from the other data as well, the lower the rating difference, the higher the chances of winning. Now let's move on to the next block. In the next cell, we have written the code for time control analysis. So what this does is analyze games by time control type, shows the distribution of games across different time controls and includes win rates and average rating for each time control. And let's run this. This will also take upwards of 4 to 5 minutes to run because of our huge data set and low compute. Let's just wait for it. And here is our output. So this output summarizes the chess game statistics grouped by time control across four categories. The first one being time class, the type of time control being blitz, bullet, rapid, and daily. These are the type of chess games played. The second thing is total games, which is the total number of games played for each time class. The third is white user win rate, the average win rate for white players in each time class. The next is the average rating, which is the average rating for the games played in each time class. Now let's move on to the next cell. And in this, we will be doing a player analysis. It will create player statistics including games played and win rates, filters for players with more than 5 games, and it will help us identify the most successful players. Let's run this query. Second, I accidentally ran that again, so let's just cancel it. And here is it. Let's wait for this query to run and then I will explain what the output signifies. And we have received the output and it took around 2 minutes. So the output represents statistics for players who played as white and had more than 5 games, ranked by their total number of wins. In the columns, there is white username, the username of the white character player, the total number of games played as white, and total number of games the player won as white, and the average white rating of the player across all their games. The key insights include that Ali Syed Ali Sayed played the most number of games, that is 880, and has the highest number of wins, 470, with an average rating of 1665. And players like 51 Fun and Abdu underscore 001 have significant game counts 553 and 502, but with lower ratings like 625 and 1581 respectively. The table highlights players' performance trends and skill levels by combining win count and average rating. And let's move on to the next cell. In this, we will be doing a rating distribution. So what rating distribution will do is group games into rating buckets and shows how many games fall into each rating range and will also help us understand the skill level distribution. Let's run this. Oh, my bad. I ran the above one again. And let's just wait for this to run. And here is our output. This output shows the distribution of chess games based on average game rating grouped into a 100-point rating bucket. So, rating bucket represents the average game rating rounded down to the nearest 100. So, 100, 0 to 100, and 100 to 200 in terms like that. And count is basically the number of games played in each rating bucket. What we get from this data is that the number of games increases as rating move from 100 to 1200, peaking at 1200 with 5980 games. And after 1200, the count gradually decreases as rating increases, reflecting in fewer players and games in higher rating ranges. The higher rating ranges 1800 to 2000 have significantly fewer games, with the 2000 bucket having only 615 games, and lower ratings, meaning 100 to 500, also have fewer games, likely representing the beginners or infrequent players. This data indicates that the most games are played in the mid rating range around 1000 to 1500. Now let's move on to the next cell. In this, we will be doing an outcome analysis, and it will analyze the game outcomes, shows relationship between outcomes and rating differences, and helps understand the skill level distribution. Let's run this. And here is our output after about 2 minutes. And this output provides an analysis for the outcomes of chess games based on result for white players. So the columns here, the white result, this the results for the white players example, win, timeout, stalemate, etc. are displayed here. The count is the total number of games for each outcome, and average rating difference is the difference of rating between the white players and the black players for each outcome. And average game rating is the average rating for the games for each outcome. So what we get from this data is that win is most common result, which is 25,799, with white typically having a slightly higher rating of plus 50 difference. Timeout. So the games that ended in timeouts were 7,939, and there were times then when the white player resigned was 8,549. These are the other frequent outcomes, and with the white often at a slightly rating disadvantage. Outcomes like 3 check and king of the hill are very less common, like 108 and 62, typically involving lower rated players with an average rating of 900 to 935. So the draw outcomes like repetition, stalemate, and agreed show small rating differences 1 to 4. You can see 1 agreed for 3, repetition also 1, and time insufficient around 4. And with a very rare outcomes like 50 move, I have a very few games, which is 4, involving higher rated players with an average rating of 1566. Now let's move on to the next cell. In here, we will create a visualization. Let's run this. Conversion to pandas ran successfully. Now let's create the first visualization. And the first visualization we will be creating is a correlation visualization between the white rating, black rating, rating difference, and white won. Now let's print the correlation matrix and let's run this. So here is the correlation matrix. All the diagonal values will be 1 because it's white against white and black against black and rating against rating. So, white rating against black rating is zero point 0.9, while black rating against white rating is also 0.93. As you can see, these values will remain similar, so you can view just either the top section or the bottom section of the graph or the chart while selecting only the diagonal values. Now let's go on to the another block, and here we will create a heat map. So let's type the command for the query plt.figure. Let's run this. This will create our correlation heat map, and here you can see this is basically the correlation matrix converted to a heat map form. And now let's go on to the next cell block. In this, we will be rating distribution visualization. Let's write plt dot figure size equals to 15. And this will be a histogram for the data. As you can see, the most number of play rating, so around 1200, 1300 as the maximum number of games played. And that's all for this session. And thank you very much.